So responsiveness and monitoring. How do you pick an aptX threshold, and how important is it to get it right? And excuse me. And what are there tools that can help you monitor so that you get alerted when things go bad? So is response time important? Yes, response time is important. Now, granted, you're not Amazon, you're not Google, you're not any of those people. But what the effect, if those companies do measurements on what happens if you essentially introduce an artificial delay into the user's experience, those companies have enough users that they can actually measure, in a statistically significant sense, the effect of that one change on their service in terms of their user behavior. So this was done not quite 10 years ago, I think. Amazon did a study where they injected up to 100 milliseconds artificially of latency into the response, and they saw a 1% drop in sales. 1% doesn't sound like a lot, but 1% of Amazon is a lot. Yahoo did the same thing back when Yahoo was relevant. Yeah, I know. They injected up to a 400 millisecond delay in search results, and they got 5 to 9% drop in traffic. Google did it. They injected up to a half a second delay, 20% fewer searches. So that's extremely noticeable, right? Speed is not an optional thing. There's also two sort of classic studies that are striking because even though they were done more than 30 years apart, these were studies of people using interactive applications. And the idea was the user does something to the application and how much time elapses before the application sort of visibly responds so that they know they did something. And what both of these studies found is that if something happens within 100 milliseconds, it's basically the same as instant, right? So in some sense, there's almost no point in getting below that threshold because from the point of view of human perception, that's kind of the shortest interval people experience. And if it's greater than 7 seconds, that's when people's attention starts to wander. Like that's when you're in danger of losing them. Or if you have a competitor site, that's where you're in danger of having them click over to your competitor's site. That's called the abandonment time. Now, of course, the reality is if the user is doing something important, like some online banking thing, they're not just going to abandon, right? They're going to wait. But the point is they're going to be annoyed, because that's the threshold at which, if it was a non-critical task, they would have abandoned it already. And these two studies done 30 years apart confirm the same thing. So that suggests that there's something about our brain wiring. And by the way, there is an intermediate threshold in there of about a couple of seconds. There's a threshold beyond which the user loses the sense of causality. So what I did is what caused the app to react that way. That's a little bit less relevant for SaaS applications because the application doesn't sort of do things on its own, right? It tends to do things when the user stimulates it in some way. So these thresholds are actually pretty stable and well established. And they have led Google, and in particular Jeff Dean, a Google fellow, to coin the phrase, speed is a feature. And Google has an enormous collection of tips ranging from the very basic to the extremely esoteric for people who want to make their web apps respond faster or even make their static pages load faster. They have done a great deal of research about this. Having said that, before you dive into this developer's website, there's a number of sort of low-hanging fruit things you can do to make sure that you're getting the basics right in your app. So we're going to start with that. So if speed is a feature and if responsiveness is so important, where does the time go? So if you're looking at an application that is running as a cloud app, first of all, when the user's browser, by the way, the column down on the right, this is sort of one column of the SaaS servers. This is a second column. The column on the left is the timeline as seen by the user. So the request has to travel across the network, right? Time goes down the page, but usually getting across the network is not the critical step. That's not in the critical path. When it gets to the server, it's got to be processed by some piece of hardware. It's got to be routed to an appropriate web server, which is connected to an app server for your app. So in our case, that all happens within Heroku somewhere. Then from our app, probably it's going to try to do something interesting with the database. So that's a component. Then it's got to render the views or whatever the response is. Maybe it's just a JSON object if this is an API. And finally, it has to go back out through the OS and network stack and start sending packets back to the user's web browser. And we can distinguish, so the response time is when everything is done, but we can distinguish this intermediate point that used to be called time to glass. I know a lot of you are young, but this is when actually monitors were made of glass instead of LCD. So people called it, the time to glass is basically when does something first appear that kind of looks like the page the user is expecting to load. So from the time the first byte is delivered, well, it can't render the page with just the first byte. But web browsers have become pretty good at, as soon as the HTML is loaded, even if the other assets are not yet loaded, like images and JavaScript and so on, there's enough that it can sort of start rendering the outline of the page, and the user's like, ah, something's happening. So that used to be called time to glass. Maybe now it's called time to LCD plastic or something. But there's usually a longer gap between time to glass and the time that the entire page has been loaded. So at this point, all of the rendering is done. Any JavaScript has been loaded. Any external assets like images and things have been loaded. And the page is basically ready for anything to happen. Right? Browsers spend a tremendous amount of effort to do as much work as they can during this interstitial here. So as soon as things arrive in the browser, they get loaded. And when we talk about JavaScript next week, one of the challenges it presents is that your JavaScript code may begin to run before your page has been fully loaded. And you need to sort of be aware of that fact when you're writing code that sort of assumes the page is going to look a certain way. So like I said earlier, this is what most people sort of think response time looks like. It's a nice bell curve. So people who are 2 standard deviations out are getting response times that are, or 95, the 95th percentile is around 2 standard deviations out. So those are the users that are still getting served somewhere within 2 standard deviations of your target time, which is here. In reality, that is not what response time looks like at all, because I showed the real example from the previous slide. Here it is again. And just sort of superimposing, if you actually look at the mean, the average, if this were a bell curve distribution, the mean of all these things is here, right? The median response time is there. And as you can see, the mean and the median look nothing like the bell curve. And in fact, if you ask the question, what is the behavior that 95% of users are getting, right? What guarantee can I make to say 95% of users will do no worse than this? It's way out at this point. And you can see that this is actually even farther out than what Apdex recognizes, right? This is way out on the tail of Apdex. So clearly, this 95th percentile is way more than 2 standard deviations of a bell curve out. But this is really more what real life looks like. So if you're the designer of the site, really what you're worried about is this stuff out here, right? What is the experience that most of your users are having? And if the best you can say for 95% of users is it's no worse than about 6 3/4 seconds, that's really far away from your Apdex target time. So those are the kind of things you look for when you're monitoring your site to understand where the time is going. So what tools can you use to help you do that? That brings us to a discussion about monitoring. And the rule of people who do operations is if you're not monitoring something, it's probably broken, which is kind of a harsh way of saying if you're not monitoring it, how do you know it isn't broken? What are the things that you can monitor? At development time, there's actually quite a bit of monitoring you can do so that even though the performance of your development machine is probably nowhere near your production machine, the kinds of things that can go wrong, in other words, the conditions that could cause bad performance in production, can often be detected in development, and you can sort of fix them before you go to deployment. So for example, later in today's lecture, we're going to talk about how to detect if you're doing needlessly abusive database queries. Those queries will still run faster in production than they will in development, but they're abusive. And that fact can be detected in development before you deploy. And then, of course, in production, there's at least 2 kinds of instrumentation, and they're both really important. Internal is instrumentation that in some sense is embedded in the app. So it can get its hooks into the Rails framework. It can get its hooks into the app server. If you want to answer questions like, in a typical request going through my app, how much time is spent in my controller method? How much time is spent looking up stuff in the database? How much time is spent rendering a view? So you basically want to break down the pieces of a request. You need to have hooks in the framework that will let you do that. On the other hand, the other kind of instrumentation is the kind that probably your users care more about, which is from the outside, what does your site look like? Does it work? What is the response time? And in fact, from the outside could really mean anywhere in the world. So to do a good job with the second one, you actually want to be sort of sending probes to your site periodically from all different places to simulate the idea that your users could be anywhere. So internal monitoring is obviously important to help you develop the app and sort of tune the app's methods to not cause needless bottlenecks. But external monitoring is sort of the gold standard because it's kind of like, to the same way that cucumber scenarios are in some sense more realistic because they represent what a real user would do. In a similar way, you could say that external monitoring is more representative because it tells you what the user experience is like from the outside. And it's not just that if your site is down, you can detect if your site is slow for reasons that can't easily be measured by the internal monitoring. So as an example, suppose it's the case that I have my internal monitoring set up, from the moment my controller gets the request to the moment that my view is rendered and it's been sent out into the world, right? My internal monitoring is going to capture all that and hopefully tell me some interesting intermediate points in between where things are happening. But if the problem is that I don't have enough servers allocated, so users are actually lining up in a queue waiting to get into the app server before the controller even sees that request, right? That is something that, depending on the kind of internal monitoring you use, may not be visible to you because it isn't inside your app, right? That's queuing that's occurring at the moment before your app gets control of the request at all. It's happening in the web server tier. So having a handle on what the big picture looks like as seen by the users is what you get from external monitoring. New Relic, which is one of several monitoring solutions, but it happens to be a nice add-on that, with one click, it sort of just works in your Heroku app. And by the way, you should just have New Relic turned on for your Heroku app all the time. The free tier gives you a lot of useful information. I'll show you some screenshots from a real app in a moment here. But typically the way it works is that there's some piece of the monitoring system. In this case, there's a New Relic gem that you would have to include in your production section of your gem file. That's the piece that actually hooks into various parts of the Rack app server, the Rails app, and actually instruments when interesting things happen to a request. And then there's also a piece that usually runs outside. So in this case, it runs, for example, at New Relic itself. That will do some external probing where periodically, like once every couple of minutes, it will send a predetermined type of HTTP request, which you can define what it is. It'll send it to your app, and it'll make sure that it gets back a response within a reasonable time frame that you specify, and that you can do some simple checks on the content. So the simplest thing you can think of is get it to load the home page of the app. Something that doesn't require login, it's stateless. You know exactly what you expect the answer to look like, so you can check for the presence of particular strings on the page, just like you would do in a really simple cucumber scenario. And you just have it, once a minute or so, ping your app and make sure that it's still running. And if more than 2 or 3 in a row get missed, then you can have it alert you and do something. And then tied into all of the instrumentation that's being collected is some application that you, as the app owner, can interact with, and you can see all of that monitoring. This is New Relic plugged into one of my Heroku apps. By the way, look at my awesome AppDex score. I'm doing so great, 0.96, but I have my AppDex threshold set really high. It's set at like 7 seconds, so I am totally cheating. I can change it at some point, but the truth is the app is relatively low traffic, so I'm not that surprised. But here's sort of the last few hours of just requests coming into the app, and you can see that it's color-coded by where the time is being spent for each of those requests. So this sort of very light green is request queuing. That is, Heroku has accepted the request from somebody's browser, but the app server is too busy, and there's sort of a queue, and the request has to wait in line before the app gets to handle it. Right? So that's an example of one of those components of waiting time that is definitely experienced by the user, but in some sense is not the fault of your app stack because your app hasn't even gotten to touch it yet. Middleware is basically things like Rack, time spent in the Ruby interpreter, which you can see the light blue actually accounts for the majority of time on most of these requests. Accounts for the majority of time on most of these requests. Time spent in the database, Postgres. For the most part, it's pretty small. There's a few requests where it's a little bit larger. Web external, like here. That is my app making a call externally to some other service's API and how long that takes. Right? If my app is blocked, waiting for the response to come back, again, that becomes part of the response time experienced by the user. So I'll show you more of that in a moment. And then the outline of all of those, right, the sort of convex hull, is the response time. I'm just on the free tier, but even if I scroll down here, I get a bunch of useful info. For example, it's telling me that the place order method in the store controller is the transaction or the kind of interaction a user might do with my app that overall has the longest average service time. So you can see that even the other slow actions in my app, all complete in under a second. But for whatever reason, this one is twice as long. It typically, and I believe those are averages over the time window of the previous graph, which is like 12 hours. So why does this one take twice as long? And I can imagine, especially if my AppDex threshold was lower, I might say, OK, well, I want to go in and figure out how can I make my AppDex better? Well, one thing I could do is I could find which operations are the slowest ones right now. I could also find how often those occur. And if the slow operations are ones that occur frequently, I should focus my effort on what can I do to make those go faster. So if I click through that, which just in case I had internet problems, I did on another screen here. So here's a bunch of different methods in my app that are sorted by the slowest average response time. And there's place order right at the top. But if I look over here, and now it's breaking down, when these requests happen, where is the time going? Look at this brown. This brown, if you can't read it from back there, says it's the Stripe API for doing credit card payments. Notice, by the way, that the New Relic hooks are smart enough to actually figure out that that's what I'm calling. So it's actually looking at the outgoing service request and figuring out what site they're going to. And what you can see from these little spiky things is that almost all of the response time of these requests is dominated by time spent out there, right? So it'd be great if I could make my place order action run faster, but the majority of the time it takes to run is the time that Stripe takes to return a response to me. So unless there's some way I can figure out how to do that call faster, like, I don't know, maybe there's like a higher level of Stripe service that I'm not paying for or something. But in general, what this tells me is I'm not going to have a lot of luck improving my responsiveness by working on that method, because most of where it's spending its time is not something that I control. And this is sort of, the first insight of trying to do any kind of performance tuning is before you change anything, try to figure out where the problem is. And having this kind of monitoring makes it way easier to figure out where the problem is. I could also sort these by most time consuming, which isn't the same thing, right? So, and this is useful to know too, because although place order still shows up here, but if I sort these by where is the most cumulative time being spent, store controller index actually accounts for nearly 40% of the time spent in my app total by everybody. So that would suggest that maybe a better investment of my time, if I want to improve performance, is maybe I should go after that method, because that's the method that most users are spending the most time in. Therefore, that would be a good one to speed up. Also, if I can speed up the methods that are most frequently called, I can serve more users with the same number of dynos, right? So if you think of a dyno as basically a serving engine that can serve one user at a time, and there's a queue building up behind it, if you don't have enough dynos, the people who are in that queue, they're going to start seeing those queuing delays that I showed on the first page, right? You're going to have more people waiting in this request queuing phase, which happily right now, you can almost, there's like little teeny bits in here, but it's almost insignificant. But a benefit of finding the most frequently used actions and making them faster is I can get them out of my pipeline quickly. So the implication is with the same number of dynos, I can serve more users, right? So it depends on what is, if all you're trying to improve is make response time low and it doesn't matter what it costs for now, find the ones that are taking the longest and see if the place they're spending your time is something under your control. In particular, for the ones where it's the database taking a long time, I'm going to show some techniques that you can use to try to speed those up. But sometimes what you find is that it's not your fault. So this and everything on here, this is just the free tier of New Relic. I don't work for New Relic. I'm not an investor or anything. I just think it's kind of a cool service. And given that the free tier already tells you way more information than before platform as a service, getting this level of detail would have been really painful. So I just leave it turned on all the time. And yes, you can set it so that if your AppDex ever drops below a certain threshold, or if the average response time over some short window goes above a certain threshold, you can basically have it notify you. You can have it send you an email or text you or something. And that's super useful as well, because believe me, you want to get that email from New Relic as opposed to getting it from your customer. And sometimes just rebooting the app is enough to sort of make the problem temporarily go away. So this is why I'm a fan of New Relic. what can you do when it's an external call to an API and it's not your fault? So there's a couple of things, right? A lot of APIs will have two different versions of a call, synchronous and asynchronous. And in the synchronous version, you make the call and you sit there and wait for it to come back. In the asynchronous call, you get a response immediately, but the response says check back later for what really happened. So you can use the first version of the second version, the async version, as a way to show something to the user. And maybe what you're showing to the user is just like a spinner saying, you know, transaction and process. And then you check back later and you get the real answer. But if it's a synchronous API, like, you know, in my case, 2 seconds is about what it takes to call Stripe and get a response back. There's nothing I can really do about that. Well, that's not true. What can I do about it? I can't do anything about that two seconds that Stripe takes, but I can make sure that everything else around that, the parts that are my fault, are squeezed down to the minimum. So if I know that I can't do anything about the delay of Stripe, at least I can make sure that I'm not making it worse by adding delays inside my app that I might have been able to avoid, right? And this is, by the way, this is actually Google's philosophy. Their philosophy is that any app that you put on top of Google is going to add latency. So their goal is to drive Google's latency like close to zero, because then it's not their fault, right? Which is an admirable thing to do. That makes them a better person than me. OK, I had some static screenshots here, but honestly, the best way to get familiar with New Relic is go to your Heroku app deployment and just add New Relic as an add-on. It's free, and it just works. The only thing you have to have is the New Relic gem in your gem file. And I think you have to get an API key so that they can report results back to New Relic. But you'll get some amazing insights on what your app is doing. Even if you're just sort of playing with your app interactively in your staging server, you will get interesting new insights on where the time is going in your app. Highly recommended.